All right. Some of you said you needed help with the pH homework, so here we go. So let me try to figure out if I can help you out here. For the first one, I gave you examples on how to do all of them. It said finish the reactions when acids are added with water. So remember the acids. So if I have HCl, all acids lead with H. Okay, so HCl will lose that H, right? So that H is going to be lost, become an H positive. So as soon as I put it in solution, it's going to become an H positive, right? If it's with H2O, that H positive then is going to add to the H2O. Right, so that H2O, if this H leaves the chloride, you'll see that the chloride in this state right here is neutral. Right, so that states there's neutral. So if I take a positive away from it, what's going to be left is chloride, right? Because I took a positive away and it was neutral, so I have to have a negative. Plus, now if I add the H to here, now I have 3 H's, and this was neutral. Since I'm adding a positive charge, it will have an overall positive charge. So for the second one, I have Cl minus plus H3O positive. Okay, so that's all you're doing, is you're taking the H away from the acid, adding it to the base. If we look at C over here, all right, so C doesn't lead with an H, so if I have NH3, it's hard to picture, but NH3 has an extra pair of electrons right here, okay? So it doesn't lead with an H, so it's not going to be an acid. It has an extra set of electrons, so it's going to be a Bronsted-Lowry base, so it can accept a proton. I have H2O here. Water does lead with a H. It has extra electrons as well, so it can accept hydrogens or it can give hydrogens. In this case, the hydrogen is going to be transferred that way. Right? So you'll see that both of these compounds have a neutral charge right now. Right? So if this accepts a hydrogen, it's now going to be NH4. It's going to have a positive there because it took a positive charge. And if water lost one, it now becomes OH minus. Okay, so that would be for C. All right, so down here, and these are called conjugate acid-base pairs. So if hydrochloric acid is an acid, right? And then what it's left after it donates an acid is its conjugate base. If water is a base, acting as a base here, then after it gains a hydrogen, it'll be an acid. So it'll be its conjugate acid. Okay, so that's all it's asking here. So H2O, if I removed a hydrogen, kind of like I did right here, right? I removed a hydrogen there. So if I remove a hydrogen, I have OH, and since hydrogen was positive, it'll be negative. If I have H3O, which is positive, if I remove H positive, or a way to think about this is minus H positive. Minus H positive, right? If I remove a positive charge, right, so you'll see that this gets removed here, right? So I remove one of the hydrogens, and then I have H2O. Okay, so I remove that hydrogen and that positive charge. All right, so the base here, these are all bases. It says what happens if I add a hydrogen. So these are all plus H plus H plus. Right, so this becomes H3O positive because it was neutral, and I added a charge. You'll see that HCO3 bicarbonate has a negative charge, so if I add a positive to a negative, it cancels out. So I'll add another hydrogen there, H2CO3, and it has no charge. Okay, so that's how you do that. All right, so which of these is a conjugate acid-base pair? All right, so you're looking at which ones differ by a hydrogen ion. Okay. So you'll see with the first one, if I took H2O plus H positive, I would get H3O positive. So this is a conjugate acid-base pair. The second one, for B, if I took OH minus plus H positive, there is no way I could get HNO3. So that is not a conjugate acid-base pair. So I would not circle that. All right, so that's how you do that. So number 5 is calculate the hydrogen ion in solution. All right, so we have our constant here, my concentration of H, plus my times my concentration of hydroxide must equal 1 times 10 to the negative 14. So for this, you just set up your equation here, H positive. Remember, see brackets means concentration, 2.0 times 10 to the negative 2 equals 1 times 10 to the negative 14. Right? So I'll take this. I'll move it here. So I'll take that and cross it out. I'll move that over here. And realize I put times 10 to the negative 3 here, but this is actually 2. Right, times the negative 2. So I'll solve that on my calculator. And I'll get 5 times 10 to the negative 13. Alright. So I can estimate the pH of this. But if I do the pH calculation for this on my calculator, this is a pH equal 12.3. So I'll know that this is basic. Okay? So I'll know that. So you do number 6 the same way. Number 7 says convert into pH. Okay, so if I look at number 1, so number 1 is hydrogen positive, and this is a function of concentration, so molarity is concentration, so I just have to simply put it into my calculator. So in my calculator, I type the negative sign, I type the log, it gives me a parenthesis, and I can put 0.0015, close parenthesis equal, and from that, my paper, because I solved it earlier, I get a pH equal to 2.8. Right, and then that would be an acid. Because remember, pH scale 0 to 7, 14. So this is basic. This is acid, and 7 would be neutral. Okay. If I look at C, it's a little different. I can go negative log. .7 times 10 to the negative 4 So when I do that, I get a POH, because remember this is concentration of hydroxide, equal to 3.49. I know that here, pH plus POH is equal to 14, so I can do 14 minus 3.49 equals pH 10.5. Right, and then this be basic. Okay, so that's how you do that. Number 8's done the same way as 7, except for you're going to POH instead of pH. Remember, so POH, scale 0 to 7. So POH, since I'm talking about hydroxide, this would be a base, this would be an acid, this would be neutral, because it's the opposite of pH. Okay? Kind of, you saw up here, my POH was 3.9. If I put it down here, it would be basic. It's still basic. Okay? Alright, so 8, you do the same way except for that. 9, this right here is your concentration. So pH is equal to negative log 0.156. And from that, I get the pH equal to 13.2. Oh, sorry, 0.807. So my pH 0.807. My POH then is equal to 13.2, because 14 minus 8.807 is 13.2. You could continue it on further and get concentrations if you want, but that's fine for me. All right, so number 10 is not solvable really without understanding. So since my max, my pH scale goes from 0 to 14, I can't have greater than 14. I can't have less than 0. So if my molar concentration is too high, right, and this is hydroxide, so my POH would be its max of 14, right, because it's greater than 1. So pH is equal to 0. Alright, so you can solve on your calculator, but you get an answer that doesn't make sense. So it's just those things. Alright, so I hope this helped you out, and good luck today on your pH quiz.